All right. Good morning, everybody. Lovely to see you all here. My name's Andy Wilkinson. I'm the lead of the Spring REST Docs project. I work for Pivotal while I also work on Spring Boot. But this morning I want to introduce you to the concept of test-driven documentation and how Spring REST Docs can help you document a RESTful API and why you might want to consider a test-driven approach for API documentation. So the first thing I want to talk about really is why. Why should you use a test-driven approach when you're trying to document your API? We'll talk about why first, and then I'll go into talking about how you can use Spring REST Docs to follow that approach and demo some of the things that it can do for you. So one of the main benefits that you get from taking a test-driven approach to your API documentation is that it gives you some level of guarantee that the documentation is going to be accurate. Because your tests are involved in creating the documentation, it means that your documentation itself is tested. The information that's included in the documentation is known to match the service that you're trying to document, otherwise the tests would have failed. And that could be a really big advantage over some of the other approaches where you're relying on static analysis of source code combined with annotations where things can easily get out of sync. And I think it's really important for your documentation to be accurate because it's if you like, it's a salesperson for the service. So you're trying to document it, you want people to use the service, you want people to trust it. One of the first things they're going to look at is your documentation. If your documentation isn't accurate, then they're quickly going to get frustrated, and a mistake in the documentation can kind of taint the perception of the service as a whole. So I think it can be a real benefit for a service if people have confidence in the documentation and they know if they go to it, what the documentation is telling them will also match the service that they're trying to use. Another benefit of a test-driven approach is that it lets you write your documentation in what I consider to be the right place, and I'll explain what I mean by the right place. So if you consider a Spring MVC or really any kind of modern web framework, you generally have some sort of POJO or some sort of object that you're trying to send back to the client. So we're considering a response here. So we have a POJO, some sort of object, and we have a controller. So the controller's trying to send this POJO back to the client, but after the controller, there are other things between that and the actual HTTP response. So maybe your controller might have a POJO and return a Spring MVC response entity. Is everyone here familiar with response entity in Spring MVC? Yeah? So maybe you wrap it in there to add some headers to the response, for example, alongside using the POJO to supply the body. Then if you're serving JSON back to the client, Jackson almost certainly gets involved. And it might be looking at some of the properties on your POJOs, maybe some of the annotations on there. Maybe you have some custom Jackson serializers plugged in that are shaping the actual response that gets sent back to the client. And then eventually, when all those things have finished their work, you get to the actual HTTP response. Now, if you take an annotation and kind of static code analysis based approach to your documentation, what you're writing is generally at the controller level. So you're maybe introspecting the request mappings on there, maybe adding a few annotations to provide some extra information. But as I've just shown, there are other steps in between the controller and the HTTP response that actually get sent back to the client. Where you really want to be writing your documentation is the HTTP response. And this works for requests as well. So the request is coming in and then it might be going through Jackson before it goes through a few more layers and eventually hits your controller. If you're trying to write your documentation at the level of the controller, you're kind of 2 steps removed from what the client is actually sending and is actually receiving. And that means that you're in the wrong mindset. You're thinking about Java objects when you're writing the documentation, when what you should actually be thinking about is what was the HTTP request going to look like? What's the HTTP response going to look like? The test-driven approach lets you actually work with actual HTTP requests or actual HTTP responses or mock equivalents of those if you're using Spring's mock MVC framework, so that what you're actually documenting is what a client for your service will be dealing with. And that can be a real benefit in making sure that your documentation aligns with the service and removes a lot of the kind of ceremony around trying to document it on the controller level when actually what you're documenting is a couple of steps removed. Another benefit of the test-driven approach is that it allows your controllers to be dry. You don't end up repeating things to satisfy the requirements of the documentation library that you're using. So here's a typical, simplified for the purposes of example, Spring MVC controller. And we have a method here, create, that is accepting a user input object, and it's going to respond with an HTTP created, an HTTP 201 when the user is created, and it's returning some HTTP headers that will probably have a location header in there telling the client where what the URI of the newly created user is. And we're also using an exception handler. That could be on some controller advice, for example, that means that if one of our methods here throws an illegal argument exception, then we want to respond with a bad request. So if we just focus in on the create method and the returning of the response entity, if you were taking an annotation-based approach, so this example here is using the annotations from Swagger, from Spring Fox, which is Swagger's Java library. We've added these two API response annotations to describe to the documentation system what the possible responses are here. But the problem is our controller is no longer dry because we've now got the bad request mentioned in two places, and similarly, we've got the created response mentioned in two different places. And this is, while it's fine at the moment, other than the repetition, it kind of comes with all the problems that repetition usually brings. You're running the risk now that your documentation is going to get out of sync with the service because you might change your API. Say you decide to stop returning a created response, and you just decide, once a user's created, the body of the response is going to be the actual new user that was created. So I don't need, it's going to be a 200 response now, and maybe the location header goes away. You've now got to change that in two different places, both to keep the documentation happy and to keep the implementation happy. Another benefit, so I've kind of talked about the downsides of trying to use annotations to write the documentation. A logical step on from that is that if you don't use annotations, it makes your documentation easy to write. I don't know how many people here would say that they genuinely enjoy writing documentation for their APIs? Yeah, not many. If you're doing a task that you don't enjoy, doing it with tools that are bad for the job is just going to make you hate it even more. I can't promise you that using Spring REST docs will be an epiphany for you and all of a sudden you'll love writing API documentation, but hopefully you'll hate it a little bit less. So if you're using annotations to write your documentation, you're stuck in your IDE and you don't have access, you're not in a normal text editor, which might have all sorts of kind of nice support for previewing how the documentation works, maybe syntax highlighting for any markup that you're using in the documentation. You lose all of that. And if you separate out your documentation from the code and take the test-driven approach with Spring REST docs, it lets you write your documentation in Markdown or Asciidoctor that you can just write in any old text editor, and then you get all of the benefits of the Markdown or Asciidoctor ecosystem and all of their capabilities in terms of including tables in the documentation, formatting things, tables of content, cross-references between different sections of the documentation. And it just moves you into an environment where you're using a tool that is designed for the job. Asciidoctor and Markdown were designed for writing documentation, writing text for people to read. That was never the intention with annotations. So I think that can be a big benefit and hopefully makes writing the documentation a little bit less painful. All right, so that was why. Hopefully you're convinced or somewhat convinced that there might be something to this test-driven approach. I'd like to talk now in a bit more detail about how it actually works and then take you through a demo. So the first thing that you do is you write some tests. So you have a test for your service, and hopefully you already have them for testing things that you know that with a certain input you get the response back that you expect. And Spring RESTdocs kind of builds on top of those tests. So you take integration tests for your service, add Spring RESTdocs to them, and that will generate some snippets for you. So we saw these in the keynote on yesterday morning, where in the weather app you saw some little snippets being generated. So your tests start generating these snippets for you, which help to describe your API. And then you include those snippets into some handwritten documentation. So this is stuff that's written in a text editor, written in either Asciidoctor or Markdown. How many of you are familiar with Markdown? Pretty much everyone. And Asciidoctor? Okay, so I think pretty much everyone put their hand up at least once then. Just to very briefly describe for anyone who didn't, Asciidoctor and Markdown are both documentation formats where the markup is very lightweight. It's not like HTML where there's tags everywhere. And it's quite easy to read once you've written the text, even though it's marked up to maybe put something in a monospace font or to link somewhere or to include a table. It still looks quite readable. So it's easy to read without actually turning it into HTML, which also makes it easy to write. So you take your tests, which generate some snippets. You then add that to the handwritten documentation. And the handwritten documentation is, this is the stuff that you can't really auto-generate. This is where you're using English or whatever language is appropriate for your users to describe your service. Maybe it's precise API documentation, so you want to describe in great detail what each resource in your API does. But it could also be like a getting started guide where you're walking people through a scenario and say, right, first step do this, second step do that, third step do that. And RESTdocs can help you make sure that the examples that you include for each step are accurate so that when you're trying to introduce someone to your service, they won't be frustrated because the steps that you're describing to them are an accurate representation of what the service can do. So you take that handwritten documentation with the snippets included, and then you generate some HTML. And the HTML generation is handled by a plugin in your build. So if you're using Asciidoctor, it's incredibly easy. There are both Maven and Gradle plugins for Asciidoctor. You just add those to your build, put your Asciidoctor source files in a well-known location, just in the same way that you used to. You have source main Java. I think with Asciidoc, it's source main Asciidoc. You put your files in there, and the build plugin runs as part of the build, and HTML pops out the other end. So here's an example of a test using mock MVC. How many of you are familiar with Spring MVC's mock test framework? Maybe half of you. So mock MVC basically gives you a way of testing your controllers without actually firing up a servlet container. So rather than dealing with actual HTTP requests and actual HTTP responses, you're dealing with mock HTTP requests and mock HTTP responses. So you're still at the right layer, you're still at the right level in terms of the documentation because you're dealing with actual requests and responses, but you're just not actually sending anything over the wire. Spring MVC is handling that for you and routing it through the dispatcher servlet to the right controller, but it makes sure that all of your Jackson and all of your message converters and things run on the way in and way out. It's just a slightly lighter way of testing an HTTP-based API. So what we're doing here, this is based on the weather app that was in the keynote yesterday. So we're performing a GET request with the beginning of the UI kind of elided for just to fit it on the slide with two request parameters. So there's country and city. So we're trying to get the weather for a particular location. So here we're putting Spain in for the country and Barcelona in for the city. And this is just a very simple mock MVC example. Normally you'd code more expectations in your test, but here we're just saying, yeah, okay, I'm expecting an HTTP 200 and OK response. But mock MVC has many more places where you can set expectations. You can say, I expect a particular header to be in the response, or you can assert things about the body. If the body's JSON, it has support for JSON path. Who's familiar? How many of you are familiar with JSON path? How many of you are familiar with XPath? So JSON path is basically like XPath, but for JSON. So rather than having to deal with maybe a map and do, get foo from the map, then get bar from the map, and then assert that baz is 5, you can say to JSON path, right, I want foo.bar.baz to be 5. So it lets you kind of provide a path into a bit of your JSON payload to say, right, I expect that bit of the payload to look like this. And the mock MVC stuff has built-in support for that, for asserting the structure of your responses. So this is where Spring RESTdocs starts coming into the picture. So the and do method here is basically a hook point in mock MVC that basically says, and do this thing now. And this thing is, you have an awful lot of control over what you can do. And it basically gives RESTdocs access to the mock HTTP request that was sent to the service and the mock response that came back. And this document method returns a handler that can deal with that request and response. So here I'm saying I want to document the weather. And the weather here, the string there, that just controls which directory your generated snippets go into. So here now I'm saying, right, I want to document the path parameters. So there were 2 path parameters. We had the country path parameter and the city path parameter. So I'm just providing details of those and the name of the country, a description for that one, and name of the city, a description for the city path parameter. And what will happen here is if the URL that you've called didn't have a country path parameter or a city path parameter, the test would fail. And it would say, no, sorry, you've tried to document a path parameter called country, but there wasn't one. Equally, if you'd only documented city and hadn't documented country, your test was also fail because there is a path parameter being used in the URL that you haven't documented. So this is where you start getting the accuracy benefits because RESTdocs is checking for you that what you've actually documented matches the request and response that have been sent to and received from the service that you're testing. And then similarly, you can document response fields. So I'm saying I expect a field called name with a description name of the data. And then here at the foot of the slide and this .weather fields, this is using a feature I'll talk about a bit more in Spring RESTdocs 1.1, where you can reuse existing snippets. So here there are some fields that were common to multiple responses that this service can give. So rather than forcing you to document them every single time, you can kind of set that up once, maybe in a private field in your test somewhere, and then you can reuse that description for anywhere in your API that those bits are reused. So you don't need to repeat yourself in your API, which saves you effort, saves you trouble keeping things in sync, and also means that you're describing things consistently across the whole of the API. So what does that produce? So you get, for free, just the document call without setting up any documentation of path parameters or response fields, request fields, and things. RESTdocs will automatically generate a little snippet for you that shows you the curl commands that is the equivalent of the request that you've made. So if you're trying to provide a getting started guide for someone for your API, RESTdocs, if you write a test that says, right, I want to check, you're trying to walk someone through the flow of doing something in your API, you can guide them through and say, and look, here's how you do it using curl. And you provide them with these auto-generated snippets, and you know that they match the service that you've tested because RESTdocs assures that that's the case. You'll also get an HTTP snippet. This is new in 1.1, a contribution from the community. HTTP is a command line utility similar to curl for sending HTTP requests from the command line. A little bit more sophisticated than curl in some ways. Gives you kind of quite nice color coding of the responses, and the syntax is a bit more sophisticated. You can kind of use some more Unix command line type things by piping stuff into the HTTP command to send a request body, for example. You'll also get a little snippet showing you what the HTTP request looked like, and similarly, I'll show you that in a minute. Yeah, get one that the HTTP request looks like, and then we get into the things that you're getting because you added some extra calls to your test. So we looked at those path parameters calls saying we want to document the country and city path parameters. So here, RESTdocs has auto-generated, this is an Asciidoc table. So there's a parameter and description columns in the table. And so we're saying there's a country parameter, name of the country, city, name of the city. Those descriptions are coming from your test. And it also includes, in the path parameters, it includes as the title of the table, the URI that you're calling so that you can see those parameters in context in the URI for the resource. You'll get, so coming now on the way back out, you'll get an HTTP response snippet. This is, again, one that's kind of generated for free. Once you add that document call, you don't need to set anything else up. You just get one, which you can then choose to include on your documentation or not, as you see fit. And you get one, so in the example that we looked at, we documented some response fields. So you'll also get, similar to the path parameters, you'll get a table for all those response fields describing the structure of the response. Again, auto-generated by RESTdocs, so you get the assurances that it's accurate because your test would have failed if you hadn't documented something that was in the response or you had documented something that wasn't actually there. So I talked earlier about, so you take these, you have your tests, they produce the snippets, and then you take those snippets and you incorporate them into some text written in Asciidoctor or Markdown. So this here is some, a little bit of Asciidoctor. Hopefully you can see that it's fairly readable. It just looks like plain text. The markup is very lightweight. The interesting thing, the particularly interesting thing here in the context of RESTdocs is that we have a couple of includes here. So this is, Asciidoc has built-in support for pulling in another file into your documentation. And it basically, imagine that you'd taken that path parameter snippet that we looked earlier and copied and pasted it into the document. That's really all it does as kind of a pre-processing step before it generates the HTML. So here you're saying, right, I want to include the path parameters and I want to include the curl request. So you're going to get the table with the path parameters and you're going to get the curl request snippet that's equivalent to the call, the test, the call that you made in the test. And that's what the HTML looks like. So you've got the text that was written in Asciidoc combined with the table and the curl command. And Asciidoc formats it all for you and color codes it, syntax highlights things, and what have you. And there's a huge kind of ecosystem around Asciidoctor. You can generate PDFs. It doesn't just have to be HTML. And you can go nuts if you want to. Provide custom CSS if you don't like the default styling. It's really easy to change the appearance of it, change the layout. Well, I say really easy. If you know CSS, it's really easy. If you're a mortal, it might be a little harder. But you have an awful lot of control over how the resulting documentation will look and how exactly it's laid out and formatted. So I covered a few of the snippets there. There are a bunch of other snippets that RESTdocs can generate for you. Personally, I think one of the most important ones is that it also has support for Hypermedia. How many of you are familiar with the concept of Hypermedia in a REST API? About half. So what Hypermedia does is it gives you links in your responses. So it moves you away from relying on people understanding the URIs in your API and knowing, oh, it's this URI to access this particular resource. And instead, in the response, there's a link which says, given the current state of the system from this resource, these are other places that you can go. And there's two benefits there, really. One is that it makes your client much more loosely coupled to the server. You're not hard-coding URIs. Instead, you're following these links. So the links have a relation on them, which is like an identifier for the link, if you like. So rather than having to understand the exact URI that will be used for a particular resource, you just need to know the relation that goes in the link. So if you're looking to go from the foo resource to the bar resource, you don't need to know the bar resource's URI. You just look for the link with the bar relation on it and then use that URI. Just grab it from the response and use it. So there's that loose coupling, and it also gives you an opportunity to, if the system is in a state that a particular resource doesn't make any sense, so say, for example, you're modeling something where you're like an order processing system, and the order has been dispatched, there's no point giving them access to anything, a resource that might let them change the order, for example, because it's been dispatched and it's too late. So rather than allowing them to access that resource and then returning a response saying, no, you can't do that, you just don't include the link in the response. So you're representing the state of the system in the responses rather than having to kind of code that one step away in the actual resource saying you can't do it. And then there's a bunch of others that are kind of similar to the things that we looked at earlier. So we looked at response fields. There's also support for request fields. Request headers, so you can document that this resource understands particular HTTP headers and what you can use them for. Request parameters, somewhat similar to path parameters. So say your resource might support sorting the results, ascending or descending, so you might want to document those. New in 1.1, there's basic support for request parts. So if you have a resource that supports a multi-part upload, you can document the request parts, the names and what each particular part is supposed to provide. And then similar to request headers, you can also document response headers. Okay, so now I'd just like to take you through a little bit of demo of some of that in action. Is that readable at the back, or do I need to make the font bigger? Bigger? Fine? No, bigger? How's that? Good? Okay. So this is the Keynote app. So we can run the tests here. Assuming that it decides to run them. So we can run the test here, and so we've got our two tests here have passed, and we're testing. There's two different endpoints. There's one for the weather, which is how the weather looks just now, and then there's also one for the weather forecast. And you can see here, these are the things that we talked about earlier, where I'm documenting the path parameters and the response fields. And running those tests has given me, in the target folder, I've generated these snippets both for the weather. So as I said earlier, the weather thing here is just controlling this output directory. So it just gives you a directory per test where all your snippets are grouped together. So it lets you identify which ones, so you can include them in the right place in your documentation. And you can see here all of the snippets that are being generated for you. So that's all looking good. But say, for example, I'd forgotten to document one of the parameters. So say I don't document the country path parameter. If I now run the test, we'll see that the request there has failed, the test there has failed. And those of you at the back will have to take my word for this, but it says path parameters with the following names were not documented, and country. So the country path parameter wasn't documented. So here you're getting if you forget to document something in your test, you're getting some assurances that you'll catch that and you won't ship documentation to people that's out of date because RESTdocs is catching it for you. And similarly, if you document something that isn't there, so say you mistakenly thought that there was also a continent parameter, and you run your test, you'll also get a failure, but this time saying that the path parameter, the following names were not found in the request. So you're now getting the opposite. So you've documented something that wasn't there rather than failing to document something that was. And you also get that that support for when you're documenting the actual request or response body. So say I document forget to not document the name field, but document something else by mistake, if you run that, you will also get a response back that says the following parts of the payload were not documented, and it actually shows you the parts of the payload that weren't documented, kind of the formatted JSON. And then similarly, it also says fields with the following paths were not found in the payload. So it's saying I failed to document the name part of the payload, and I've also tried to document the bar part of the payload, which didn't exist. And you get that support for requests and the bodies of requests and responses, request parameters, path parameters, HTTP headers, all those kinds of things. REST docs will check that the request you sent and the response that's come back actually match what you've coded in your test and what is going to appear in the documentation. So the Asciidoc file that's involved here is just tucked away in source main Asciidoc. There's kind of a bit of preamble at the top. This is just kind of standard Asciidoctor stuff for setting things up. So you give your a name to your documentation, the author, what type of documentation you want to produce. So you want to produce a book, or are you trying to produce a PDF, or what format do you want it to be in? And there are a bunch of, Asciidoctor refers to them as backends. There are a bunch of different backends which control what format the Asciidoctor is rendered into. You can configure a source highlighter, which is really nice, so it will kind of do code highlighting for different parts of your requests and responses, color in your JSON payloads and things, make them all look a bit nicer, a bit easier to read. You also get support for things like tables of content. So you can say to Asciidoctor, I want all of my headings to appear in a table of contents, which can make your documentation easier to navigate. And then the rest of it is really just fairly simple plain text, nice and easy to write with just lightweight kind of markup. So the backticks here, you're probably familiar with these, let you format something into a monospace font, which is a bit easier to read in certain cases, and when you're referring to a variable or a URI, that kind of thing. And then as we saw earlier, you're just including those snippets into the documentation. And when it all pops out the other end, you see something like this. So here you can see, the title that we've configured, the table of contents on the left-hand side, all of the different headings, and the table that was produced by REST docs, the curl example snippet, details of what a typical response might look like, and then similarly for the weather forecast things as well. And then the other piece, just to show you quickly, there's also in your POM file, adding Asciidoctor to your build is really just a case of just adding the Maven plugin, and it's the same for Gradle. Here, one thing that's worth pointing out is I've bound this to the prepare package phase. So that means that Asciidoctor is going to run and produce the HTML before my jar file gets created. And that can be really useful if you combine that with Spring Boot support for serving static resources, because you can then include the generated HTML in your jar file so you can serve your documentation as static content alongside the actual service that it's documenting. All right, so I think we've got about 15 minutes left. So I just wanted to talk to you a bit about what else is new in 1.1. I've mentioned a few bits and pieces. So one thing that's coming is support for REST Assured. How many of you have heard of REST Assured? Not quite half, probably. So REST Assured is a Java DSL for testing basically any service that you can access via HTTP. So unlike the mock MVC stuff that I described earlier, which uses mock HTTP requests and responses and is tied to an application implemented using Spring MVC, REST Assured can be used to test any API that is accessible via HTTP. It sends actual HTTP requests to the service and deals with actual HTTP responses. But you get a similar API to what I showed you for mock MVC, so you can set expectations and assert things about this is how you expect the response from the service to look like. And you can, in a similar way, you can plug in REST docs into REST Assured, so REST docs can get hold of the request that was sent and the response that came back, and then can document things in exactly the same way. Big benefit is that it means that you can test stuff that doesn't have to be written in mock MVC. So there are people, for example, in the Groovy community are using it. So Ratpack is quite popular in the Groovy community. It's a very lightweight web framework. Doesn't use Spring MVC, but people are using REST docs to document RESTful APIs implemented using Ratpack. Similarly with Grails, while Grails builds on top of Spring MVC, it does so in a slightly unusual way, which means that Grails apps can't be tested with mock MVC, but the REST Assured support means that you can still use the REST docs to document those APIs. And you can even use it now, because it can talk any service that you can talk to via HTTP. You might be trying to write a guide for someone, say this is how you use this third-party service. And now you can do it because REST docs coupled with REST Assured, you could document something using the Twitter API or the GitHub API, and you actually make HTTP requests to the GitHub API or the Twitter API, whatever you like, and document it if you're trying to describe to someone the steps that you need to take to perform a certain task using those APIs. And you can do that now because you don't need access to the source. You just need to be able to send HTTP requests and receive HTTP responses. Another addition in 1.1 is support for Markdown. So focus mostly on Asciidoctor thus far. That's because, in my opinion, it is a better format for writing documentation than Markdown because it's much more sophisticated. Asciidoctor has built-in support for things like tables, tables of content, cross-referencing in your documentation, all those kinds of things. Markdown in its default format doesn't really have that. But there is a big community that's built up around Markdown to kind of add some of those capabilities to it. And you can now take advantage of that with RESTdocs 1.1 because you can configure it to produce Markdown snippets. I've highlighted a project called Slate here, which is a Tripit project. So it's basically, it's like a pre-canned kind of library and layout for API documentation. So it takes Markdown and then lays it out in a specific way that's very well suited to API documentation. The long URL at the foot of the slide there are a bunch of samples in the RESTdocs repo, and that shows you how you can use Slate with Spring RESTdocs. So if you don't fancy writing all of the, the Asciidoctor gives you a very clean slate, a very, scope to do whatever you like, and that can be very useful, but it can also be a bit intimidating. So if you fancy being guided a bit more about how to structure your documentation, Slate is well worth looking at. Another thing coming in 1.1 is support for relaxed snippets. So I've talked so far about how RESTdocs will make your tests fail if you document something that isn't there or don't document something that is. And that works really nicely if you're trying to write detailed API documentation. But if you're trying to document a specific scenario, a series of steps that you want someone to take, you might want to focus in on a specific piece of the request body or a specific piece of the response. And you don't really care. The other things are kind of a distraction at that point. If you use relaxed snippets, RESTdocs will no longer complain if you fail to document something. So if there's something in a request body or response body and you don't document it, the test won't fail. However, if you document something that isn't there, then the test will. So you get assurances that what you're documenting exists, but you don't also have to go to the effort of documenting absolutely everything. So it's useful for kind of scenario-style stuff rather than detailed API documentation. And the other thing was reusable snippets, where I described earlier, you can set things up to, say, for example, document 4 fields, which are common across multiple responses, and then reuse that. So rather than having to rewrite the documentation or copy and paste it every time you're documenting those fields, you can just reuse a snippet and say, and these fields as well, please. And it saves you a bit of time, saves you a bit of repetition. So I think we've got about 10 minutes left. So I'd just like to now touch on what makes good documentation. So I've talked about the test-driven approach and the benefits that it can bring in terms of the accuracy and how you can use Spring RESTdocs to do that. But there's still another step which I think is important in writing good API documentation. So the accuracy part of this, RESTdocs can help with, and hopefully it does a good job of that. But the structure of your documentation, I think, is also very important. You need to make it easy for people to find what they're looking for in your documentation. So one thing that you can do to structure your documentation nicely is to be consistent in your API. So be very consistent with how you use HTTP status codes, HTTP verbs, any authentication or authorization in your API, rate limiting, for example. If you do that consistently across all of the resources in your API, then that allows you to just document them once in like an overview section to say, if you're using this API, here's all the things you need to know. We do this consistently across the whole API. So for example, your API is rate limited. You might document the HTTP headers that you use to convey the rate limits to a client and tell them how long the window is, how many requests they have left in the current window, that kind of thing. If you do that consistently across your whole API, you can just document that once up front. And then anywhere in your API that anyone needs to know that, they can just refer back to that. You don't need to keep mentioning it. So then the other thing that I think you need to document are your resources in your API. And I say resources here very deliberately. I don't mean URIs. You shouldn't document URIs because they're not really that interesting. They're only interesting at the point where you're making an actual request. When a user comes to your documentation, they're not thinking about /API/weather/ country/name or country/city. They're thinking, right, this is a weather API. How do I get the weather for this particular city? So you need to structure your documentation in those terms. Basically, as you would structure an HTML page, we have links in HTML that help people navigate around. We don't expose the URIs to people. We use descriptive text for the actual thing that you're linking to, which put things in terms of where people are trying to go. You go on Amazon and you're trying to buy something, you can go to the different categories using descriptive text that describes and helps people navigate around. You need to do the same thing in your documentation. You need to describe things in terms of the problem domain of the API, not the URIs that you've actually used to turn it into a RESTful API. They're kind of almost an implementation detail. And when you're documenting those resources, so describe what they represent. So this resource represents, so we'll look briefly at the GitHub API in a bit. So this particular resource represents issues in a particular repository. That's the useful information, because then someone looking at your documentation go, I want to list the repository's issues. So they go to the issues section of the documentation, not the /API/repository/foo/issues URI, which it takes them a bit longer to parse that URI and go, oh, that one must be for issues. And then you should describe what input they accept and what output they produce. So what does it look like if you get it wrong? It looks a lot like this. How many of you is that familiar to? Have you seen? So that's Swagger. And in my opinion, it gets a lot of things wrong in terms of the structure of the documentation. It focuses on the URIs and the HTTP verbs. They're on the left-hand side. So they're the kind of things that it's saying to you are most important. I don't agree with that at all. The actual useful information is on the right-hand side. It's here. It's telling you, I need to find a pet, create a pet. So the classic pet store example here. So this, in my opinion, this documentation would benefit from being restructured to talk primarily about the thing that it's dealing with and not the URIs that are being used to do that. Another problem that it has is that it's listing all the HTTP status codes for every single resource. And that shouldn't be of any interest at all. And in fact, this is wrong. An HTTP 405 is a method not allowed, which is a very strange thing to return for invalid input. So there's an accuracy problem here, but there's also a fact that it shouldn't be of interest for this resource. So that should be standard across your whole API. You should always be using the same response codes as defined in the HTTP spec, so you don't need to mention them and document them on every single resource. And if you get it right, I would recommend, how many of you have looked at GitHub's API documentation? So I would recommend, when you have a minute, just Google for the GitHub API docs and have a look, have a navigate around and see how it's structured and take inspiration from it. It's structured, in my opinion, really, really nicely because everything's broken down in terms of the problem domain rather than URIs. So you can see here, we're looking at the page for issues, and there's a list of things I can do here. I can list issues for a repository. I can get a single issue. I can create an issue. And there's all these things to navigate, right? If you're thinking, I need to use the API to create an issue, you can see a textual description of where you need to go in the docs to do that, rather than the URI that you then need to look at, oh, okay, well, that's a post to that URI, so that probably means creating an issue. I'll go and read that documentation. So I strongly urge you to follow GitHub's example and structure your API in terms of the problem rather than the URIs. Right, that's all I had. Thank you very much. There's my email address there, or Twitter handle if you want to get in touch, you have questions. A link to the GitHub repo for REST docs, and also the Spring project website. And happy to take any questions that you might have now as well, if anyone has any. Yes?
Hello? Okay. The fields for constraints would be the default next release?
Support for documenting constraints?
Yes.
Yeah, I didn't describe that at all. So there is support, and this was in 1.0 actually. If you've used the Bean validation API to set constraints on a POJO that's involved in your API, RESTdocs has an API that you can use to say, grab the constraints from this POJO, and it will then generate descriptions of those. So say you've got an @NotNull and an @max or whatever annotations on there. It will grab those for you and then give you an API that you can use to include in the descriptions of the fields in the API.
So it gives you another column?
You can add, so because of the, it's kind of getting into the details, RESTdocs uses, to generate the snippets, it uses mustache templates. So you can add a custom template to change how things are.
I need to override templates.
So you provide a template to add another column, yes, and then you use the API to add like a constraints column and include the description of the constraints.
I wondered if that would be default next time.
No, it's not the deep, because I very deliberately don't want to get into the business of trying to automatically figure out, oh, this is the POJO that was involved in creating that HTTP response, so this is where I should grab the constraints from. So you have to give RESTdocs some hints. You have to call something and say, this is the object that ends up being the JSON, so these are the constraints that are involved. So there are, admittedly, and there's an extra couple of manual steps, but it means that we can stay true to the kind of documenting everything at the HTTP request and HTTP response level, rather than trying to second guess what your controller's doing and how it then turns stuff from a POJO into JSON.
Okay, thank you.
Yes?
You take into consideration to introduce JavaScript in the HTML output so that you can make dynamic, you can try the API directly, a bit like we've seen in
with Swagger. Yeah,
but maybe even more advanced, but nevertheless in this direction, or Python and JavaScript snippets, because the users of the API are not only curl users. Yeah.
So the interactive kind of console-y thing is a common request. I'm torn on it. I don't know if it's a good idea or not. I think I can see a benefit. My concern is that if you give people a web UI that they can type stuff into form fields to send requests, you haven't really taught them how to use the URI. You've taught them how to type stuff into a web page. And I'm not sure that that's as useful as showing them this is the curl command, so this isn't, or this is exactly what the HTTP request looks like, because then they can map that to whatever language they're using. So you were saying maybe it's a JavaScript client or a Python client. So I don't know. Someone's also was asking about generating Postman collections, using RESTdocs to generate a Postman collection. So a Postman, are you familiar with Postman? For those that aren't, it's kind of somewhat similar in that you can have pre-canned kind of request and response descriptions, and then you can use Postman to send them to the services in a similar area, but not exactly the same as an interactive console. For the other stuff, for JavaScript and Python, yeah, you could add those. The snippet stuff is completely extensible, so you could add another snippet. The difficulty is that there are many different ways to send an HTTP request in JavaScript, depending which of the 3,000 different libraries you're choosing to use. Python is probably similar. So if you had one that you know your clients are going to be using because it's a company standard or whatever, maybe it's an internal API and you know everyone is using jQuery, for example, you could plug in something that looked at the HTTP request object that was sent and then figured out what the equivalent jQuery call would be. There's nothing in REST docs to do that. I wouldn't be against adding it if it was for something that was as broadly used as jQuery, for example.
Just to add on that, a very nice combination is using the HAL browser. If you happen to use HAL, which gives you that executability thing, and then basically using queries to point to the REST docs generated APIs to have the things side by side. Yeah, so those, just very quickly, because I think we are running out of time. HAL is a hypermedia format that it basically describes exactly, well, not exactly how, but it puts some constraints on the format of your responses and specifically defines the format that the links should take. So I described a bit about the links linking between resources. And HAL can look at those links and help you navigate around your API by clicking in a browser because the format of the response is sufficiently constrained that it can kind of figure out what to do. And it also has support for an interactive console not as sophisticated as Swagger. And then the other thing that Ollie mentioned is you can actually serve links in the response that link to the REST docs documentation. So you can add this browser, or if anyone using curl, they curl your API, they do a GET request, they get a bunch of links, and one of those links is a link that is to the HTML documentation. And it's kind of, so almost the API almost becomes self-describing at that point. And all you need to do is do a GET request to the root of the API, and then all of a sudden you see a link to go off and start reading the documentation. So there's some definite benefits there, but it is kind of a different way of thinking if you want to start using Hypermedia in your API. All right, I think we're probably out of time. Thank you very much, everyone.